Okay, we're going to continue working with our sine, cosine, and tangent, but some of these are going to move outside the unit circle. So if negative 2, 3 is a point on the terminal side of theta, find the sine, cosine, and tangent. Okay, well, where is 2, 3 at? Here's my xy axis, left 2, up 3. So there's 2, 3, so my terminal side goes through here. Now, I want to get my reference angle, which always goes to the x-axis, so down this way. Here's my theta. Here's where I want to make my triangle. How did I get to this point out here, which I extended? Well, I went negative 2 left and 3 up. So I can solve for the missing side of this triangle. 3 squared plus negative 2 squared equals, what is that, 9 plus 4, 13. So this must be the square root of 13. So now I can go through all my trig functions. Sine theta equals opposite over hypotenuse, so 3 over radical 13, or 3 radical 13 over 13. Cosine theta, negative 2 over radical 3, or negative 2 radical 3 over 3. Oh, I meant 13. There we go. Tangent theta, opposite over adjacent, 3 over negative 2. Got it. Okay, try this one. This time the point is 8, 15. Find the sine, cosine, and tangent. Okay, on my x-axis, if I go to 8, 15, I'm going to be up in the first quadrant somewhere. Here's my triangle. I went right 8, up 15. Find the missing side of my triangle, comes out to be 17. So now I know my sine theta is 15 over 17. Cosine theta, 8 over 17. And tangent theta, opposite over adjacent, 15 over 8. All students take calculus. This is a handy way to remember where positive angles are. Starting with quadrant 1, all students take calculus. Now, so in quadrant 1, we know that all of our trig functions are positive. In quadrant 2, our sine and our cosecant are positive. Everything else is negative. In quadrant 3, tangent and cotangent are positive. And in quadrant 4, cosine and secant are positive. So, a handy way to check your work, just to make sure you have your signs correct. All students take calculus. Okay, so knowing what's positive where, we're going to start looking at these types of problems. So we're given that our sine equals 4/5 and our tangent's less than 0, which means negative. So my sine theta is positive and my tangent theta is negative. So what quadrant do I have to be in for my sine to be positive and my tangent to be negative? Well, for sine to be positive, I can either be in quadrant 1 or quadrant 2. So which of these two quadrants is tangent negative? Only in quadrant 2. So that's where my triangle is going to go. That's where my theta is going to fall. My sine equals 4/5, so that's opposite over hypotenuse. So my opposite is 4, my hypotenuse is 5. So this is a common triangle. Now my missing side has to be 3, but not just 3, it's negative 3. Find cosine theta, adjacent over hypotenuse, negative 3/5. Cosine is negative. Should it be negative in quadrant 2? Yes. And cosecant theta is the reciprocal of sine, so that one should be an easy one, 5/4. Okay, on this one, figure out where your terminal side is, then work on your trig functions. So pause it, try it, come back. If sine is 0, sine always has to do with my y-coordinate. So if my y-coordinate is 0, I have to be somewhere on the x-axis. So I can either be here at 1, 0, or I can be here at negative 1, 0. So I have to look at my other stipulation. My angle is in between pi over 2 and 3 pi over 2. So which one does it have to be? It must be this one over here. Because if I have to go from pi over 2 to 3 pi over 2, it's got to be in between here. This is the only one that falls in there. Now I just find my 6 trig functions right here. Okay, so sine theta, sine has to do with the y-coordinate. Y-coordinate is 0. Cosine theta, cosine's the x-coordinate, negative 1. Tangent theta, tangent is the y over x. So 0 over negative 1 or 0. Reciprocal identities, cosecant theta, flip over 0, you get 1 over 0, which is undefined. Secant theta, flip over negative 1, you still have negative 1. Cotangent theta, flip that over, gives you negative 1 over 0, which is undefined. Okay, a little practice finding reference angles. Reference angles always go to the x-axis. So if I graph 300 degrees, which falls into the 4th quadrant, I want to know what angle it makes with the x-axis. Well, full circle is 360. I'm short 300, so I need to go 60 more degrees and I'll be there. Okay. Now I'm at 1.7. That's in radians. It doesn't have a degree sign. Well, we know pi is 3.14, so where's 1.7 going to fall? Somewhere right in here. It's a little more than half. What's the angle it's going to make? Well, if this is 1.7 and that's 3.14, 3.14 minus the 1.7 gives me 1.44. Okay, negative 135. Negative angles go clockwise, somewhere over here in quadrant 3. What's the angle it's going to make with the x-axis? Well, this is 180. This is 135. Angle in between is going to be 45 degrees. Okay, try these. See if you can get them. Try all 3. Come back and check. Angle of 144 is going to fall into quadrant 2. How many degrees does it take to get to 180? 36 degrees. Negative 246. So negative, here's negative 180. So it's going to land somewhere in here. Now, what's the angle it makes with the x-axis? This one's a little different, but 66 degrees. And then the reference angle, if theta is 2.3, again, here's 3.14, so somewhere in here. So the 3.14 minus the 2.3 comes out to be 0.84. Last type of problem, find the 6 trig functions given theta. First of all, where is 11 pi over 4? Okay, if I start counting, here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4, 5, 6, 7, 8, 9, 10, 11. So there's my triangle. Make it with the x-axis. There's my theta. What's the reference angle? If this is 11 pi over 4, how far am I away from the x-axis? Pi over 4. With a pi over 4 triangle, I know my two side lengths, radical 2 over 2, radical 2 over 2. This bottom one has to be negative. Then I just go on like normal. Sine theta, opposite over hypotenuse, assumed hypotenuse is 1, we're in the unit circle. So radical 2 over 2. Cosine theta, negative radical 2 over 2. Tangent theta, opposite over adjacent. Well, they're the same number, one's negative, so that's going to come out to be negative 1. Cosecant theta, 2 over radical 2, or just radical 2. Secant theta, I mean negative radical 2. And cotangent theta, still going to be negative 1. Now check this. When we're in quadrant 2, what's positive? All students take calculus. There's also a smart trig class. So there's different ways to remember it. Anyway, sine's positive here. So sine's positive. Everything else needs to be negative. Positive, negative, negative. Okay, try this one. First find negative 750, then find your functions. Go clockwise. I've got negative 360, negative 720, and I've got to go 30 more degrees. That ends up being my reference angle, 30 degrees. Make my triangle. This is the short side, so this is 1/2. Long side, radical 3 over 2, hypotenuse 1. The vertical distance must be negative. So now we start. Sine would be negative 1/2. Cosine, radical 3 over 2. Tangent, opposite over adjacent, negative 1/2 over radical 3 over 2. And if we multiply by the reciprocal, I get negative 1 over radical 3, or negative radical 3 over 3. Then my cosecant would be negative 2. My secant would be 2 over radical 3, or 2 radical 3 over 3. Cotangent, negative radical 3.